Welcome back. Now we know how to set an actor's location and rotation, but we can also add an offset as well. Now I'm going to go to BP item and I'm going to drag off of begin play and search for add actor world offset. Now this requires an offset rather than a location in space. Notice it's called delta location, this input, which is a vector. So what this function will do is take an offset that we provide and add that to the actor's location. And of course we have sweep and teleport options. We're going to leave those alone. Now, if I add an actor world offset to the item, such as adding 200 to the Z, then in begin play, we'll move the actor up by 200. But we know this happens first before our C++ code gets executed. So we would just be setting the actor location back down to 0050 and we wouldn't see any change. So what I'm going to do is simply remove these two lines where we're setting the location and rotation. And I can go ahead and save and come back to the editor and hot reload. Now if I go ahead and hit play, we'll see that those actors were no longer set to 0050 as we took that code out, but instead we're adding a world offset of 00200. So they've been raised up by 200 units in the Z direction. Now we can do this for rotation as well. We can add an actor world rotation. So let's search for add world rotation and we see add actor world rotation. Now I'm going to change the pitch value. Let's change it by say 45 degrees. And now if I hit play, I can look up and see that we've changed the pitch. So it's like they're looking up by 45 degrees now. We've rotated these actors about their local Y vectors. So adding an offset can be useful, especially if we'd like to change our actor's location and rotation every frame to give a continuous movement. So we're going to see how these work in C++. I'm going to go ahead and remove those nodes and hop back into Visual Studio. And I'd like to add a world offset every frame so we can see our actor moving. But we won't be able to see that with our debug sphere because we're only calling this in begin play. I'd like to make a new macro to draw a sphere for a single frame. That way we can draw the updated location every single frame. So let's head back over to debugmacros.h and make a new version of drawSphere, which does not use persistent lines, but instead will draw the sphere for a single frame. So let's define a new macro, and I'm going to call this draw underscore sphere underscore single frame. And this will take a location just like drawSphere does. So I'm going to copy the line where we've defined drawSphere, and I'm going to paste it right here for drawSphere single frame. But I'm going to change it a little bit. This last input, this Boolean, is for persistent lines, and I'm going to use false for that. Now we're no longer using persistent lines. And if I hover over draw debug sphere, I see that after that B persistent lines input, we have the lifetime. Now, if we want to draw this for a single frame, then the practice is to use -1.f for the lifetime. And this will result in drawing the sphere for a single frame only. Now we can make single frame versions of draw line, draw point, and draw vector as well. So let's do that. Just after my draw line macro, I'm going to define another macro called draw line underscore single frame. And it's going to take a start location and an end location just like draw line. And I'm going to copy my draw line definition here and simply paste it right here for my macro definition. The only difference is I'm going to change true to false for draw persistent lines. And if I hover over draw debug line, we see that after B persistent lines is the lifetime here, which we already have set to -1, so we're covered there. Now let's make a draw point single frame. So let's go ahead and define that. So we're going to define draw point underscore single frame. Now, this requires a location. And we'll go ahead and copy our draw point code and paste it right here. And instead of true for be persistent lines, we're going to pass in false. And after that is the lifetime, for which we will pass in -1. Now I'd like to make a single frame version of our drawVector function as well, so I'm going to copy this entire thing and paste another one just beneath it, only this one will be called drawVector single frame. And the difference here is that we're going to pass in false instead of true for persistent lines, both for drawDebugLine and drawDebugPoint. And of course, for drawDebugPoint, we need to pass in -1.f for the lifetime. And that needs to be .f, not /f. So now we have single frame versions of these. And these are great for calling in the tick function. So we'll go back to item, and I'd like to simply remove my code from begin play. So now we're doing nothing in begin play. We're going to do things in the tick function now. And the first thing I'd like to do is call add actor world offset, which takes an f vector. So I'm going to pass in a local f vector. And for this vector, for the offset, I'm going to put 1.f for x, 0.f for y, and 0.f for z. So every single frame will be adding 1 to our actor's location. Now after this, I'd like to draw a debug sphere so we can see where the actor is. So I'm going to use draw sphere underscore single frame, and this requires a location. So we'll use get actor location for this. Now the semicolon is optional, but I'm going to go ahead and add it there. And because we've added to a header file, I'm going to be safe and close out of Unreal Engine and compile from here in Visual Studio and launch at the same time with Control F5. Now we'll launch the editor back up. And by the way, this pop-up at the bottom says that an editor was open when we last closed Unreal Engine. And if we click open, we can open that back up. And that editor was the BP item blueprint editor. So I have that open again. Now, if I go ahead and press play, take a look at this. Notice our actors are moving. They're moving in the X direction. That's the world X direction because we're calling add actor world offset. So this is not moving in the actor's local X, but rather the world X direction. And they're moving every frame, and we're moving by 1 per frame, and this is a pretty smooth movement. But I'm going to show you a problem with this. You see, we're adding 1 every single frame, and we know that frame rate is not a constant. The frame rate could change. If I go to the hamburger icon and select Show FPS, I see that my frame rate is about 120. So these actors are moving about 120 centimeters per second. But that's not going to be the case if my frame rate were lower. And if I was running this game on a machine that could only handle, say, 60 frames per second, these would be moving much slower. Now we can simulate that by going to Edit and Project Settings. And if we search in the search bar for frame rate, we see under this frame rate section that we can use a fixed frame rate. And if we check that, we see that fixed frame rate by default has 30, so we would be capping our frame rate off at 30 frames per second. That's quite a bit lower than 120, isn't it? Let's see what that looks like. I'm going to go ahead and press play. Now look at that. They're moving quite a bit slower. So even though our code hasn't changed, changing the frame rate changes the behavior, and that's not good. We want these objects to appear to move the same rate no matter what our frame rate, whether it's 30 FPS or 120. And the way that we do this is by using delta time. So let's go back to item.cpp, and notice in the tick function, the input parameter here is a float called delta time, which tells us how much time has passed since the previous frame. Now, by scaling things by delta time, we can result in having a constant movement rate. So for example, if I make a local float called movement rate, and I set it equal to, say, 50.f, then in my add actor world offset, instead of 1, I could use movement rate. Now, as is, this would move by 50 every single frame, and that's way too much. But what I can do is multiply by delta time. Now, by multiplying movement rate by delta time, we're making it a lot smaller. But more importantly, we're making it smaller scaled by the amount of time passing per frame. This essentially will move our actor by this much per second movement rate. Let's think about the units of this multiplication. Let's add a comment just above movement rate, and we can say movement rate in units of centimeters per second. So movement rate is 50 centimeters per second, and delta time is seconds per frame. So right here over add actor world offset, let's do another comment here and say movement rate times delta time, and we'll have our units here. We know that movement rate is in centimeters per second, and we're multiplying by delta time, which is in units of seconds per frame. Now, we're dividing by seconds in these units, and we're multiplying by seconds in these units. And in mathematics, when you divide and multiply by the same thing, the seconds will cancel each other out, and we're left with centimeters per frame. So this is equal to units of centimeters per frame. So movement rate times delta time gives us centimeters per frame. So this gives us the rate of 50 centimeters per second, but we're chopping it down to the amount that we need to move by this single frame. So every frame, we're moving scaled by delta time, so we should see the perceived movement of this actor as a constant rate of 50 centimeters per second, no matter what our frame rate is. Let's see how this works. I'm going to go ahead and save and jump back into the editor and hot reload. Now I can close this and hit play. Now we're moving by 50 centimeters per second, even though my frame rate is only 30 FPS. Now if I go back to project settings and uncheck use fixed frame rate, now if I go back, I see that I'm back up to 120. But if I press play, we're still moving at the same rate, and that's because we're scaling our movement by delta time, which makes our movement frame rate independent. So if we're moving every frame, we should use delta time to scale that movement in order to get a constant movement rate that will be constant whether our frame rate changes or not. And the truth is, frame rate is always changing. If our game performs a large number of computations mid-game, we may see a frame rate drop. So it's important to scale things by delta time to accommodate for that. Now we're using add actor world offset. Let's see how this works if we add a rotational offset. So let's make another float here, and I'll call this rotation rate. I'm going to set this to 45.f. And after we've added a world offset, let's add a rotational offset. And this function is add actor world rotation. And we see there's an overload that takes an FQuat and an overload that takes a rotator. We're going to use a rotator. So let's make an F rotator inside this function call. And if I enter 0.f, comma, and I'm going to use rotation rate for the yaw, and 0.f for the roll. So every frame, we're adding rotation rate for the yaw of our rotation. But we want this to be frame rate independent, so I'm going to multiply rotation rate by delta time. Now we'll have a smooth rotation rate. Now in order to see this, I'd like to draw the forward vector. And we can use our handy draw vector single frame macro. So I'm going to use draw vector single frame, which requires a start location and an end location. Now I could make a local F vector, or I could simply call get actor location right here inside of this macro function call. And for the end location, I'm going to use get actor location plus get actor forward vector. But I'm going to scale getActorForward vector by 100. .f. And that way, we won't have a vector with a length of 1 centimeter. So let's save this, and we'll hop back into the editor and hot reload. Now let's see what this looks like. We'll go ahead and hit play, and take a look at this. We're adding a world offset as well as a world rotational offset. So we have constant rotation rate. Both of our actors are rotating, and this looks great. Excellent. All right, I'm going to hit the hamburger icon and disable Show FPS. We just needed that to demonstrate the importance of the use of delta time. And now we know about two new functions, Add Actor World Offset and Add Actor World Rotation. And now we have more macros in our debug macros header file to draw these for a single frame, which we can do here in the tick function to show things that are moving. So this is great. Awesome job. I'll see you in the next video.